Caleb, did you tell me, I remember last year I told you you might see this on the ACT?
Yeah, you told us that this year.
Is it the second year?
Okay.
I was like,
It's like the same thing. Because I know it was, I don't think it was on the ACT last year, but 2 years ago it was. It's function notation, it's just a weird way that the ACT wrote it. I'll explain this more, I'll actually get the actual question out of the ACT book later on. Maybe they'll do that tomorrow. Remember, little o thingy of G means put G, take G of X, substitute it in for F. So you wind up with, excuse me, X minus 1 quantity squared.
yeah, I just didn't know what that thing was.
Yeah. And like I said yesterday, a lot of this stuff is weird because you haven't seen it written like that. Until we get going with seeing it more and more often, it won't be so bad. The next one was G of, might as well do them. So we take the F equation, which was X squared, and we subtract 1 to it. Yeah.
Wait.
Remember, G of X means of G of F of X, G. That's what that means. You're taking that F of X equation and you're substituting it into the G. They're just writing it differently.
Wait, so I did it. So it's still G of X.
It's not times though. It's not timesing it. It's a composite of it. Think of it this way.
Is this 31?
If you had with
Would you
these,
just do it?
I just did it.
That's.
The answer's right here.
Is what I say or B?
That's B. And then C is F of X.
Wait, so what's A?
I'll show you one second. F of X. Remember, this means F of X. So I'm going to take the F of X equation and put it in for itself.
So X.
The F of X equation was X squared. So I put that in for X, and then I square it, and you get X to the 4. Now, I know that you guys did problems that
Oh, I did.
look like this. Let's say you had F of G of 3. With that scenario, you had F of X was X squared and G of X, X minus 1. You've done that. F of G of 3. We did that with piecewise functions. Take the value, figure it out, innermost parentheses, and work your way out. Same idea. It says take 3, substitute into the G equation, so you get 3 minus 1, which is 2. Take that value and substitute it into the F equation. 2 squared is 4. It does the same thing. Function notation means take whatever is in that parenthesis and substitute it into the equation that it's telling you to look at. Here it's saying take the G of X equation, substitute it into the F equation. The G of X equation is X minus 1. We surround it then with the F equation, which just happened to be just X squared. Because this X minus 1 substitutes in for X. The book is now writing it in terms of composite. Instead of F of G of X, they're just saying it is F of G of X. It means the exact same thing.
So
It's just the more proper way to write it. That's all. We'll get you there.
sorry.
It's okay.
So my answer is X squared
Yes, but you don't have to do that.
minus. I just read.
Yeah, you're done. You're done. Yes, please.
Number 23.
Okay. Yeah, let me put that one up. Here's 33, guys. F of x is that the x cubed plus 1?
No, that's sorry.
Oh, so this one is the cube root of x plus 1.
Yeah.
Okay. And then g of x. I don't have the pre-calc book memorized yet. I'm working on it.
I don't get it.
I'm not gonna. I know pretty much all the problems in the Alpha 2 books. Use that one a lot. This one, I'm working on it. So they're asking you in part A is f of g of x, which means take the g of x equation and substitute in that for x in the f of x equation. The g of x equation is x cubed plus 1. Now I'm going to surround that with all the stuff in the f equation, which is the cube root, and then I have a minus 1. I took this and I substitute in for x.
So the ones cancel out.
The ones cancel out, and what's the cube root of x cubed? X. Okay? You're taking the value, or taking whatever it's asking you to do, substitute in, and work your way out.
But wouldn't the next one still be x?
I don't know, I haven't done it yet. G of f of x. Write down the f of x equation first. Then surround it with the g equation. Well, this now replaces the x, so this gets cubed, and I add 1.
So it's just x.
X plus, well, you get x. Remember, the cube root of junk cubed is junk, so you get x minus 1 plus 1, which is
Just
x. Minus 1.
Plus.
I thought it was 2. That's why I made the joke if I don't have the book memorized yet.
Oh, okay.
But if it was, then you'd be right.
So you were right.
Okay?
Alright.
Now, do that again with the f of x. Well,
So would that change A because it's not?
no, it doesn't change a. It doesn't change that because the original one was write down g of x. I wrote down g of x was x cubed plus 1. I put that in for just the x. So I have x cubed plus 1, and then it still had a tag on minus 1. It didn't change it. Did you write down plus 1 for both of them? Did you write down your... Okay, let me just see what you wrote for your answer. No, erase it. Oh, no, I was just trying to see if you did, from what you wrote down, if you did it correctly.
Okay.
Which, from what you were saying here, you probably did.
Okay.
Okay? Cindy makes a good point. There are some times when you go to write stuff down, if you write it down incorrectly, like let's say you're given a function here and you start writing things down. Let's say you accidentally, you read it, but you wrote down plus 1 in here, and then you did it again here. But you did everything right. Do you know what you're doing?
Yeah.
Yes. Am I going to yell at you? No. Well, maybe. Just only Caleb. So f of x, write down the f of x equation. That was the cube root of x minus 1. That goes in for x, so then I surround it then with it just looks ugly.
Can you like simplify it?
You could, if you wanted to rewrite it all out. Remember using the exponent rules? Cube root is a 1/3 power. You can do it.
No,
Or we
Power to power, you get multiply, you get 1/9, so you get a 9th root.
We can just.
So gross.
Yeah, I want to do some of that, more of that domain stuff. We're having, it's just a little bit, it's not bad. It's just want to make sure you guys get it. Okay? There's not much going on tonight with this stuff. You guys should probably finish the homework from what you know right now. Okay. Let's go through and just kind of revisit that whole domain when we're dividing, trying to list out domains. Okay? I want to go back and look at another way of writing out what we were doing yesterday. So let's restart this problem. I'm going to show you a little bit cleaner way of explaining it. I went back and I looked at how we did it, and I thought of a different way of doing it. So same idea. When I'm looking at the two parts and they're asking me to find the domains of how the functions get divided, before this, it's one of those days.
You're getting old.
Go figure. Aren't we all?
I mean, yeah.
Anyway, what I want to do first is I want to write out the domains for the possible values of x, for f of x, and then for g of x. So what are all the possible values for f of x? Well, can it be a negative? Can it be 0? Yeah.
So anything
Greater than or equal to 0. Do you guys remember writing things out in terms of what's called set notation? Now, what we're talking about here is our domain for f of x. You guys are telling me that it is x has to be greater than or equal to 0. Agreed? Now, I'm going to change that and I'm going to write it in what's called domain or set notation. There's a hard border at 0 because it means it includes it. And then if it's starting at 0 and continuing on and on and on, what's the math term for on and on and on and on? Infinity. From 0 through infinity. Can it ever reach infinity?
So it's open.
So it's open, but we use a soft bracket, a parenthesis. It's just a, you did it. We did a little bit of this, but I'm trying to show you guys how the brackets will help us a little bit with the domains when we divide out. Okay. So you get that. So the domain for f of x is a hard bottom at 0, open top at the end because it's infinite. It goes on and on and on. All right. If I look at the domains of g of x, what is the values that'll work for g of x?
So that's 2. And greater than or equal to 2.
If it was greater than 2, let's say 3.
No, never mind. In between -2 and 2.
Good. So can it equal, did everybody hear what she said?
I got that from Canary yesterday.
He's right. What happens here is that you are still finding the 0. You set it equal to 0 and that you can help yourself go that way. We know that this has to be bound between plus minus 2. So you have a hard bottom at -2 and a hard top at positive 2. Okay?
So we can write it like that instead of
Yes. I'm trying to show you that when we start combining these things through, it's going to be a little bit cleaner to write it like that. Okay? Oh, what's up?
Oh, never mind.
Okay.
What? Wait. Okay, I have a different question. How come at the top it has it like the divided on top, but like in the domains it's like sideways?
Jeez, I have no idea.
I just like
It-
researched it up.
Does it irk you?
Yeah,
Oh. Maybe they were saving space and they went to slashy fractions.
that's what I.
Because you know how much I love slashy fractions.
Yes. You don't like it?
I hate slashy fractions. You guys get lost in slashy fractions. Like, I don't like them.
But if you're
314.
Yeah, exactly. Thank you.
314. So it's kind of sideways.
So let's do this then. If we're going to do the f divided by g, let's write that out. So we have f over g of x. Well, our f equation, I know, but I'm showing you guys a different way to write out with your domains. I'm trying to make it cleaner than it was yesterday, because yesterday you guys kind of all looked at me like I had like flames coming out of my ears, and more so than normal. So if we start looking at it like this, and we want to talk about it in terms of hard tops, hard bottoms in the domains, we know that the domain of f is anything greater than or equal to 0. We know that the domain of g, bless you, is anywhere between -2 and +2. Where do those two domains overlap?
At 0. 1, 2.
So they overlap between 0, 1, and 2. Does it include 0? Does it include 2?
Yes.
So the way that I would say that the domain for the composite function, the domain here, is the overlap of those two. In this case, my overlap works. I have a hard bottom at 0, and a top at 2. Because if you use anything smaller than 0 in that denominator, or I should say if I use, it winds up not working itself through. It's how you intersect it through. You're looking at the intersection of the domains to figure it out. That's all it is. Where do they have in common? It's a lot cleaner to work with. What are they looking at in common? Flies.
Yeah.
What's that?
There it is.
I killed a hornet in my house yesterday. I swear it was as big as a golf ball. It was huge.
The big hornet.
That's a big hornet.
There's centipedes.
Yeah.
Yeah, this is
Oh,
That's around.
No, seriously,
That's why I killed it.
Scary.
I got it with a sandal. Midair, flat, killed it.
Do you know what's up
With your hand?
With a sandal.
Centipedes. For what I've been told about the whole centipede thing, I guess it's not just our building. A lot of buildings that are next to fields and stuff right now, I think Genoa Kingston's having a problem. Down in Kingston or Kirkland or whatever it is, they're having the heat of the building draws them through. Just like on the south side of your house, have you been seeing a lot of the box elder bugs lately again?
What are box elder bugs?
Those little black and red bugs that just fly around all the time. They don't do anything, but you see them all the time. The box elder bugs will all, at this time of year, because it's still really warm during the day, they're on the south and southwest sides of your houses, that at night they all disappear. Okay?
Where they go?
Underground, in your siding, they just go all over the place. They're everywhere.
Room.
Yeah, in your bed. Okay. So, we did this, we did this, we did this, we did the composition, we did those last night also. Yeah, you know what? I just wanted to re-show you that domain thing. You should be able to finish this out without too much of a hassle now, okay? Give you guys a little bit of time. I can answer your questions with you guys as I'm wandering around. But trying to use that domain stuff as the way that it's going to work where they're overlapping themselves, and will the values make sense, okay? When you're looking at them in terms of the denominator, is it going to make them the zeros, and things like that, okay?
I asked him if we had one.
The